Yes, class. Am I audible to all of you? Shahid,
Yes, please.
then Sidra, Fadil, Deborah. All right, class. So yesterday we had completed this lesson. One portion I told you that was left to be discussed. Some of you couldn't draw the graphs, no? So I'll just show it once. So draw it, all those who haven't. Half wave, and some of you couldn't draw the full wave. So I'm just showing it for 2 minutes each. Then some special purpose PN junction diode that I told you, that is left to be discussed. That I'll discuss. Okay, now talking about the special purpose PN junction diodes. So see, you have four diodes, one which I already mentioned yesterday, Zener diode. So Zener diode has been deleted from your CBSE syllabus, so it won't come. Photodiodes, LED, and solar cell. So you just have to remember basics about it, and one graphs of each. Graphs can be asked. So what are photodiodes? See, photodiodes basically, this is how a diode looks like. So outside the shell of this photodiode, light enters. And because of the light rays, the PN junction diode is connected and the diffusion, drift, every process occurs, which we have already studied. So this covering is transparent. Okay. And this is always connected in reversed biasing. So P is connected to the negative terminal, N is connected to the positive terminal like this, which you can see in this diode circuit. And this is used to measure the intensity of the light. This is used to measure the intensity of the light. So these devices are called photodiodes. And see, this I'm not describing because we haven't discussed this. When we discuss dual nature of matter and radiation, their energy's formula is h nu. So h nu is greater than the energy gap. Or you can say energy is greater than the energy gap. This will be clear when we'll be doing dual nature of matter and radiation. Now the graph is exactly the same as that of the reverse biasing graph, which we have studied yesterday. But you should know the current which is kept below here, As soon as the graph becomes steeper, the values of current start increasing. If this is I1, this is I2. So I2 will be greater than I1. If you have I3, I3 will be greater than I2, like this. And the first value of current which you obtain, this is known as dark current. This is about photodiodes. This is what you have to remember about photodiodes. Second, you have the concept of LEDs. LEDs are similar to photodiodes because again the concept of light is used, but you have to remember that this is used in forward biasing. This is connected in forward biasing. Now you have to remember certain materials regarding LEDs. LEDs will form LED stands for light emitting diode. Now see, two types of lights are used. Red LEDs are there and infrared LEDs are there. So red LEDs use arsenic, gallium and phosphate. Infrared LEDs use combination of gallium arsenide. The entire component is used. So here elements are used, here a compound is used. So these are the materials used in LED. And the way you had the forward biasing graph with knee voltage initially linearly, then varying non-linearly, this will be the same graph for the LED. And here the current will be measured in milliamperes for photodiodes, which we have studied just before it. Current will be measured in microamperes. So milliamperes for LED, microamperes for photodiodes. Lastly, we have solar cell. So for solar cell, you have solar cell's graph is little different. That I'll tell you. First, understand this is the cell battery. Here, light will be coming or light rays can go because this is also transparent. So inside this, NPN junction is made in layers. You have NPN junction in layers. The way, unlike the other ones which are made in a single crystal lattice, here layers are made. So all the molecules which are present on the upper surface are hit by the light rays. So the entire solar energy which is coming from the sun gets converted into electrical energy and conduction of circuit. So I'll show you. See like this. This is the PN junction diode. Light rays are entering. The bounded electrons are becoming free electrons and they are going into the resistors and the entire circuit like this. Also, the graph. Last part of this is the graph. See, graph of solar cell is a little different. It is drawn in the fourth quadrant firstly. Second, the graph is always in this manner. A curve which is connecting the current and voltage. The point to be noted about it is that if you look at the current one, here current is 0. So we say this is short circuited. Okay, sorry, here the voltage is 0. So we say current is short circuited. And if you look at this point here, the current is 0 because voltage's value is present. So we say this point is open circuited. So these are the theory points which you have to remember about these devices. Only this part was left yesterday. Write it down as special purpose PN junction diodes. I hope all of you now have written the graphs of half wave and full wave rectifiers. If not, let me know, I'll scroll up. Otherwise, start writing down. Then after this, we'll complete compound microscope. Yes, class written. So, semiconductors, this lesson is completed. Atoms, nuclei, dual nature, and wave optics. These are like ray optics we have to complete. Last portion of ray optics. See, this we already discussed. We started with compound microscope. So I told you that there will be two types of lens. One where image is formed at least distance of distinct vision. So it is formed at this separation. Both lens were there and image was magnified. And final formula was V naught by U naught 1 plus G by FE. Angular magnification was the same. So we have already calculated it. Second case was left to be discussed. See, in the second case, final image is formed at infinity. So see what is happening. Object is kept near the objective lens. One ray passes through it. Please pay attention right now. One ray, this is the object. So one ray is passing, getting refracted till here. Okay. Second ray, as I have told you, this retraces its path also and passes through the optical center. Now, these rays, when this has to be formed at infinity, when you will extend this, the final image will be formed over here. That is, final image is formed at infinity. Earlier, when these two rays we produced, they were meeting somewhere here. So an enlarged image was formed at D. That is adjusted using the focus of the microscope. The rotators are there. You rotate, you adjust the slide. Everything has to be adjusted to see whatever you want to obtain. So now what will be the difference here? Everything will be the same. It's just that, see, some things will be the same. This is U naught. This is V naught. O means objective. O term means objective. E term means eyepiece. So this is U naught. This is V naught. The focal length of eyepiece is now the objective, is now the object distance. Why? Because final image, see, final image is formed at infinity. It means the object is kept at focus. This we have already studied. So that's why we are saying UE is equal to FE. Okay, class. So now see magnification due to the objective lens. When we are talking about the magnification due to the objective lens, this will be the same V naught by U naught. But when we are talking about angular magnification, see, if you remember angular magnification of the eyepiece, this acts exactly like the simple microscope objective. An eyepiece, see, two formula we have already studied. For the eyepiece, we use the formula of this acted as a simple microscope. And for this, we use the formula 1 plus D by FE, which we had obtained. And what was the formula for C? This was the formula for least distance of distinct vision. We used it. Now this is the formula for infinity. So magnification will be D by F. This will be only D by FE. So final magnification will be M naught into ME, which is equal to V naught by U naught into D by F. This was the magnification left to be discussed. One more thing, class, you can add in your calculation. Anytime you can equate. This is one formula if this is required. Magnification in both the cases. This is also equal to length of the tube by the focal length of O. So sometimes you can equate V naught by U naught equal to L by F naught in these calculations, in the previous calculation also. Just make it into a box so that you remember this. That you sometimes the length of tube is also mentioned. Length of tube means separation between the tubes. This entire separation is taken as length of tube. This is the length of tube. Note it down. Second case. See, this question says you are given two converging lenses of focal length 1.25 and 5 centimeters to design a compound microscope. Find angular magnification. Okay. Image is first. In the first case, it is given at least distance of distinct vision. In the second case, it is given at infinity. So both the formulas you have to use. For the first part, we will use V naught by U naught 1 plus D by FE. This is the formula. So D, we know it's 25 centimeters. Again, we don't have to use the sign convention here. And this is given as 5 centimeters. So see, what we'll do, this is given as, see, 5 centimeters and 25 centimeters we know. Focal length of the lens, we know. What we can do, we have no information about V naught, correct? We have no information about V naught. Rest of the things we can calculate, but we have no information about V naught. V, when you take this, see, you are given two converging lengths of focal length. See, you are given two converging lengths of focal length 1.25 centimeters and 5 centimeters to design a compound microscope. It is saying find angular magnification if final image is at least distance of distinct vision. All right, class. So D, you know, FE, you know, you have to find out magnification. One focus also, you know. One by F naught is equal to 1 by V naught minus 1 by U naught. Now here, since this is the lens formula, remember we'll be using the sign convention. All right, here we'll use a sign convention. Understood? Why are we using sign convention over here? Reason? We didn't use sign convention over here. Yes, because in lens formula, this is in lens formula, you use the sign conventions. In this formula is not through the lens formula. This is the lens formula. In lens formula, lens maker formula, every other formula you use it. All right. One more thing, object distance. Object distance is given as, let me just write it in brackets. Object distance is given as 30 centimeters. So if object distance is also given, we do not have information about V naught. U naught is given, but V naught is not given. That's why we'll be using the lens formula. Now see, 1 by V naught will be equal to 1 by F naught plus 1 by U naught. So 1 by F naught, this is 1.25 minus, because the object distance, this will be negative 1 by 30. From here, V naught you will get, U naught is already 30, and magnification you will get from it. Similarly, for the second part, you have to use the same formula without this one. For the second part, magnification will be V naught by U naught D by F. So whatever you will calculate V naught from here, put it. U naught, you have to put it D25. FE is also, and that one will be eliminated from the form. Write it. Yes, I'll show the question also. Yes, class. Now coming to telescope. So again, this is the last optical instrument. Then we'll be left with prisms. So in prisms, you don't have such topics. In prism, we'll be just solely talking about prism, its angle and all. You don't have such cases the way we had seen continuously in all the devices. So a telescope, what is a telescope? We have different types of telescope. Okay, let me just brief you with it. You have firstly refracting. Two types of telescopes are there. You have refracting telescopes. In refracting telescopes, you have two types. You have astronomical and you have terrestrial. Terrestrial telescope. And second types of telescopes you have, which are the reflecting telescopes. So basically, refracting telescopes are used to view the distant objects only. So astronomical telescope, what's the speciality about astronomical telescope? That you will be studying. This is the diagram of astronomical telescope. So here we study about heavenly objects like the sun, stars, planets and all. So final image formed is inverted one, which is immaterial in the case of heavenly bodies because of their round shape. Okay. Then these are terrestrial telescope. So it is used to see distant objects on the surface of Earth. Final image is formed as erect one in this. Here this was inverted. This we will see also. You can check here also this image formed is inverted. Here in terrestrial image formed as erect. Then in reflecting telescopes, this is also used to view the distant object, but here you use the mirror. In reflecting ones, you use the mirrors. In refracting ones, here you use the lens, which you will study. Here in reflecting, you use the mirrors. So you have Newtonian telescopes and Cassegrain telescopes. These were earlier there. One was Newtonian and one was Cassegrain. None of them is a part of your syllabus. Just focus on astronomical telescopes, two cases like this. Object is at infinity. This is just a representation to show that object is kept at infinity. It's not object is actually present. You cannot draw infinity anywhere. Okay, so rays from the distant objects are coming. They are getting refracted by the objective lens. They are coming from infinity. Okay, they are entering the eyepiece. And again, when you'll extend the eyepiece, an enlarged image will be formed. Wherever the images had intersected, you had an you can say intermediate image. Now you have to pay attention. Eyepiece becomes smaller here. Can you notice? Objective is greater. In this figure, it's not so obvious, but yes, if you look carefully, eyepiece is lesser than objective lens in terms of aperture size. So this angle is again alpha, which we had discussed initially, that without the lens, which angle has been formed. So this angle is alpha when this AB object was kept at the optical center. This angle is beta that is being subtended by the image. See, this is the image. Image is subtending angle beta. What is magnification? I have told you magnification is already beta by magnification. Magnification is beta by alpha, which we approximately write it as tan beta by tan alpha. Fine. Now again we have to substitute in the values of tan alpha and beta. And why are we equating this? Because you can notice even alpha and beta, both the angles are very small. Alpha and beta, they are small angles. That's why we are writing or equating. Now coming to tan alpha. All right. So see, this is the figure for beta. You can use. See class, if this is alpha, this will also be alpha. So if you look at this triangle carefully, if you look at this is one triangle. Okay, and this is one triangle. Correct? So when we are talking about first beta, so tan beta will be equal to A dash B dash divided by B dash E. Let me write it. A dash B dash divided by, this is B dash E, perpendicular divided by the base in this triangle. Look, this is the triangle. Okay. Tan alpha. Look at this triangle. So this is A dash B dash divided by OB dash. So this is A dash B dash divided by OB dash. A dash B dash will be cancelled. Magnification is OB dash divided by B dash E. Okay. Now what is OB dash? Look, OB dash, this is the entire focal length of the objective lens, right? If you see, OB dash is the focal length of objective lens, and this is behind this lens, so it is positive focal length. And what is B dash E? This is the focal length of eyepiece, right? Focal length of eyepiece, not the focal length of eyepiece, sorry, the objective lens. You can see the object distance. This intermediate image is acting as the object for the eyepiece. So this separation is UE. So this is B dash E, which is equal to UE. Why? Because this is this intermediate image, which is formed because of the infinity rays. This is acting as an object for the eyepiece. So if it is acting as the object, so this separation becomes object distance for the eyepiece, right? And since it is in front of the lens, this will be negative. Fine. So what is the magnification till now? Magnification will be minus F naught by UE. Simple calculation we'll do. See, objective lens is object distance is minus UE. Image distance is minus D. We are already taking the first case, right? So what will be the focal length? 1 by V minus 1 by U is equal to 1 by F, correct? So what can we substitute? This is what? This is the lens formula. So 1 by minus D minus 1 by minus UE is equal to 1 by FE. So 1 by UE is equal to 1 by FE plus 1 by D. Or you can take 1 by FE common. So this is 1 by FE by D. Now look, we just have to substitute in here. This is the value of 1 by UE. So put the value of 1 by UE. What do we get? See, 1 by UE. What do we get? Minus F naught is already there. Instead of 1 by UE, we can substitute this. That becomes 1 plus FE by D. That's it. This is the formula. Okay. And final image will be real and inverted. One more case we'll see for infinity, but just write this down first. Look, in the second case, same thing will occur. Object is present at infinity. Light rays are coming. Intermediate first image is formed. Then when you produce the rays, these will be formed at infinity. The difference is that this was the object distance for the eyepiece. Now is equal to the focal length of eyepiece. Because when this object will be at its focal length, then only the final image is formed at infinity. So here in this case, UE is equal to FE. Rest alpha is same, beta is same. I think it's better in this image also. It's more clear. Till the previous step, this will be the same. M will be equal to beta by alpha, which is approximately equal to tan beta by tan. Alpha, beta and alpha have no difference in this question. So same thing, you will get A dash B dash by B dash E into OB dash by A dash B dash. So magnification will be equal to OB dash by B dash. Now difference will be in the definition of B dash. Earlier it was just the focal length, right? So OB dash, this is still the focal length of objective and it will be plus because this is behind the mirror, behind the lens. But B dash E, this will be minus F, which was UE initially. So here the magnification will just be minus F naught by F. This will be the magnification. That's write it down. Yes, Tarif. See, object is at infinity. This is just a representation to show that the object is kept at infinity. So rays from the distant objects are coming. See, one ray is coming, it is getting refracted. Then this ray is coming, this is getting refracted. So at the intersection, an intermediate image is formed. One image is formed. Now, since this image is in front of this lens, so it acts as an object. So what happens? Further, the reflection of these images are produced forward like this because light travels in a straight line. So our eyes can never view this like this. Our eyes cannot view if the object is kept. Our eyes will always have the tendency to view in the straight line because light travels in a straight line. Okay. So this is it. When you produce images formed at infinity. Now clear, Tarif?
Yes, miss.
See class, now starting with prism. So let me just give the introduction about prism, then we'll see the details. Prism is a wedge shaped portion. Wedge shaped means we just see the triangular portion when we are practicing the questions and the diagram. We are just seeing the triangular portion. Actually, it's like two triangular surfaces are there. See, this is the triangular surface. So two triangular surfaces are present, these two, with three rectangular, one, two here and three at the bottom. Okay, these edges, these are the refracting area. These surfaces, this surface, this surface, this surface, these act as the refracting area because light will enter like this, refraction will occur like this. And this angle, which is formed by the inclination of the two rectangular pieces, this angle, this is called as the angle of the prism. Okay, note it down. This is the last topic from ray optics. Then we'll be left with four lessons: atoms, nuclei, dual nature, and waves. I'll try to take extra class this week so that your atoms and nuclei are also completed. After this, I'll start with atoms and nuclei only. Wave optics, I'll do it at the last. Okay, class, all those who have completed, you can leave. Now we'll be completing this portion in the next class. Thank you so much, class.